Hello and welcome everyone. In this lecture, I'll be discussing about the balancing of V engine. So, let us start. The V engine are two-cylinder radial engine in which the connecting rod are fixed to a common crank. As you can see over here, the two crank are connected to each other, which are at 90 degree to each other. So basically each cylinder is having angle of 45 from the reference axis, and we have to find the unbalance in V engine. So in such engine, the center line of the cylinder form a letter V, that's why it is called as V engine. And in V engine, the cylinder have a common crank, and this crank revolves in one plane. They are having one single common crank, so there is no primary or secondary couple acting on engine. There is no couple acting, only there is primary and secondary force acting because they are in same plane. So as you can see, there are common crank and two connecting rod, and the line of stroke are inclined to vertical axis through an angle alpha. Here over here we can see the mass is M is a reciprocating mass, L length, R radius of crank, and obliquity ratio. Theta is the angle of crank, omega is the angular velocity of crank, and 2 alpha is the V angle. So here there is primary force 1 Fp1, which is acting because of Fp1, which is acting because of cylinder 1. Same way Fp2, primary force 2, which is acting because of cylinder 2. And the horizontal component is here Fph and Fpv because of the primary force, and the secondary force is acting over here. This is because of cylinder 1, this is cylinder 2. So this is the secondary vertical and secondary horizontal. These are the angle. This is the crank angle, theta is the crank angle, and this is the angle with the reference axis, center of the plane. Now next, we know that the primary unbalanced force in single cylinder is m omega square r cos theta, and secondary is m omega square r cos 2 theta by n. Now the primary force in individual cylinder, the for individual cylinder, here the theta angle will be, for cylinder 1 we can see from here figure, it will be the alpha minus theta, and for cylinder 2 it will be alpha plus theta, alpha plus theta, and alpha minus theta for cylinder 1. So this is the primary force Fp1, and this is the Fp2, primary force 2. Now the total force along the vertical line, there will be Fp1 and Fp2 will have cos component. As you can see over here, the Fp2 and Fp1 will have the cos component, and this will be the horizontal will have the sine component. So the total vertical force will be Fp1 plus into cos alpha plus Fp2 into cos alpha. So by resolving this we will get the primary force because of in vertical direction. Same way, the horizontal total primary force will be Fp1 minus Fp1 sin alpha minus Fp2 sin alpha, because here both the forces are acting in opposite direction, so one is positive and another one is taken as negative. So we will get the Fp as by resolving the above equation. So our resultant force will be equal to Fp is equal to under root Fpv square plus Fph square, the square of horizontal primary force plus square of vertical primary force. So the final answer will be this. This is our final answer of primary unbalanced force. And the angle made by the resultant force angle will be, as we know that it is the tan inverse of horizontal primary force divided by vertical primary force. So this is the angle made by resultant force with the vertical axis. Same way we can find the for the secondary force. As we seen for the primary force, the secondary force will be have the same equation. Instead of 2 theta, there will be the alpha minus theta for cylinder 1 and alpha plus theta for cylinder 2. And here by putting the value of 1 and 2, we will get the secondary vertical unbalanced force. Same way we can find the total secondary force along the horizontal line. The x-axis force is taken as positive and the y-axis is taken as negative. So this will be subtracted minus fs2 sin alpha. Here it is our V engine. So what will happen? This will be minus. So this is the secondary horizontal force. Same way we can find the resultant force for the both, which is equal to under root square of vertical force plus square of horizontal force. So this is our final equation of secondary unbalanced force. Now this is the angle made by the resultant secondary force with the vertical axis. Same way as for primary force, the angle beta s secondary, for primary it was beta p tan inverse f sh upon fsb. So this is the answer. Now we will see about the variation of resultant primary and secondary force with crank angle. What if we change the crank angle and what its effect? The V engine normally built with total angle of the angle can be 60, 90 or 120. So the half angle will be the 30, 45 and 60. Now the resultant primary force, this is our resultant primary force and secondary force. So first we will consider for 2 alpha equal to 60, means alpha is equal to 30. The primary force, if we put the value of alpha in the equation, we will get this equation. Now when will be the primary force maximum? It will be maximum if we do the derivative of it with respect to theta, and which is equal to 0. So for 2 value, theta is equal to 0 or 180, the FP will be maximum. So first we put the 0 and second we put 180. We will get the maximum primary force, which will be equal to this. Same way, for the secondary force, we can find the secondary maximum force by putting the value of theta in the equation. Now let us discuss for the alpha. V angle is 90, which means the half angle is 45. Same way we have to find the primary maximum force and secondary maximum force. Here it is our primary maximum force, m omega square r, and same way the secondary unbalanced force, secondary maximum force, when theta is equal to 45 or 135 degree, we will get the secondary maximum force. Same way the third angle is 2 alpha, so alpha will be 60. We will get the primary unbalanced force as 3m omega square r by 2 for theta equal to 90 or 270. Remember, theta is different and alpha is different. In the V engine, this is our V engine cylinder. What will happen? The crank angle is the theta and the alpha is over here between two cylinder, which is the same. This is our alpha. So this is the primary maximum force, and same way the secondary maximum force we can find. Now the 2 theta should be equal to 90 or 270, which means the theta will be equal to 45 or 135. This will be our secondary maximum force for the angle 120. Now let us discuss this with an example. Suppose a reciprocating mass per cylinder in 60 degree twin cylinder engine is 1.5 kg, and the stroke and connecting rod length are 100 mm and 250 mm respectively. The engine speed is given. Now what we have to determine the maximum and minimum value of primary force, also find out the resultant of secondary force. Here the V angle is given as 60 degrees, so alpha will be half of it, so it will be equal to 30. Mass is given over here, stroke length is given, so crank radius we can find, connecting rod length it is given, so n we can find, RPM is given, so omega we can find. Now the resultant primary force is equal to FP is equal to, this is the resultant primary force. Now we know that for the angle here it is 30, so this will be the equation. And for maximum value, the d upon d theta should be equal to 0. So we have to do the derivative of this, and we will get the same final answer by resolving this equation as the theta equal to 0 and pi by 2. Same way for the secondary resultant force, we can find the Fp maximum and Fp minimum. This is the for the primary force. For there will be two angles, so here for theta 0 we will get the primary force maximum, and for theta is equal to pi by 2 190 we will get the Fp minimum. Now same way we have to find for the secondary force. Now we know that this will be maximum at 2 theta is equal, so here the alpha is 60 and we have to find the 2 theta angle. So this will be the final equation for Fs. This is the answer, secondary force. Thank you very much for watching.